outside square root is minus 9x.
Perfect. So let me read it back to you just to make sure. Limit as x approaches infinity, the square root of 81 x squared plus x minus 9x.
Correct.
Okay, so first of all, I realize that this is infinity minus infinity, and no one can decide what this means. So in this particular situation, I will rationalize with the square root of 81 x squared plus x plus 9x, the square root of 81 x squared plus x plus 9x. So this is limit as x approaches infinity. The numerator is 81x squared plus x minus 81x squared. And the denominator needs to factor. So I'm going to have the square root of x squared 81. I didn't mean to put the fraction. It's just 81 plus 1 over x and plus 9x. Because x approaches infinity, this square root of x squared will equal x, not negative x. So limit as x approaches infinity, the numerator is x. And the denominator has x, the square root of 81 plus 1 over x plus 9x. And we will factor out x and then simplify with the top. Limit as x approaches infinity. And I have x at the top, and then x, and in brackets or parentheses, it doesn't matter, the square root of 81 plus 1 over x and plus 9. These will go away. And now I drop the limit operator because I apply it. It's 1 over, this is 0. The square root of 81 is 9. 9 plus 9 is 18. So I would conclude y equals 1 over 18 is a horizontal asymptote at infinity only.
Why did you drop the limit operator?
Because I applied it. I can only drop it when I apply it.
Thank you.
Is that okay, everyone? Other questions on this one? Or anything else? Is it clear how we apply the limit operator, or is it not?
Can you go back up just a little bit to where we got the square root of 81 plus 1 over x? You factored out the x squared.
Yeah, we always factor out the
just 1 over x.
Yes, we always factor out the degree. I don't factor out x squared. I have to factor out the degree, and it happens to be 2.
Okay.
Yes. If it were anything else, of course, I expect an even degree. I hope for an even degree. Good. Anything else? Other questions? Anything else you want to work on? Now, remember that if x approaches negative infinity, this will equal negative x. And you have to put in negative x. So maybe I should remove this so it's not confusing. I'm hoping that you're going to look at this again. Good. Other questions here or anything else? Anyone else? Other questions? Do you need help with anything else? Please go back and review the reviews for chapter 2, 3, and 4.
Do you feel like there's something that between yesterday and today we haven't really gone over?
I don't think so. So maybe continuity at a point, that definition is very important. So please, graphing piecewise defined functions, everything that we discussed already in chapters 2, 3, and 4. We had a summary of all the topics for each. Anything else?
Can I ask one more question?
Yes. Yes, I'm ready. Yes, of course.
In 5.1, it's question 3. It's a table.
Yeah, let's take a look. So you.
It's actually for the lowest and
So
the
you
lowest
said.
estimate and the upper estimate.
Is this the one?
Question 3.
Oh, yes. For some reason I thought I wrote 3, but I don't know why. Okay. So only from a tank at a rate of liters per hour, the rate decreased as time passed. We see that. And values of the rate at 2-hour time intervals are shown in the table. Perfect. Find lower and upper estimates for the total amount. Very good question. So let me just explain. So the rate of change is positive.
I think my numbers are slightly different. I don't think it matters now.
Yeah, I'm going to copy your numbers in a minute. Just give me 1 second. So as time goes by, the rate of change is positive, which means the function is increasing. The rate of change is decreasing, but the function is increasing. So on an increasing function, if the function is increasing or the function is decreasing. So if the function is increasing, then the rightmost point, I'm showing the leftmost point. The leftmost point is the lowest. But the rightmost point, in other words, an underestimate. But the rightmost point will be an overestimate. So this under is, in other words, with the leftmost point, left. The leftmost point is the underestimate, and the rightmost point, so upper, is with the right, if the function is increasing. And of course it's reversed if the function is decreasing. So I can copy the table now. What are your numbers? So let me copy. It's 0, 2, 4, 6, 8, and 10. And that's,
And then my bottom,
yeah, that's the T.
8.9.
Okay.
7.5.
So that's what I see. 6.7?
6.9. It changes after.
Ah, 6.9. Oh, okay, I see.
6.4.
6.4.
5.6.
Yes.
And then 5.1.
Okay. So this is the rate of change, R of t. Find lower and upper estimates for the total amount of oil in liters that leak from the tank on the interval, of course, 0 to 10. Use 5, of course. We already have 5. I know. It's very clear. So the lowest and the upper. Okay. So we will determine the leftmost point and the rightmost point. So this is from 0 to 10. 1, 2, 3, 4, 5. So for the area with the right, I have these. The area with the left, I have these. So the subinterval, the base of the interval is 2. This one with the right will be f of 2 plus f of 4 plus f of 6 plus f of 8 plus f of 10. But the other one will be f of 0 plus f of 2 plus f of 4 plus f of 6 and plus f of 8. So AR will be 2 in front and f of 2, 7.5 plus 6.9 plus 6.4 plus 5.6 plus 5.1, 63. And the left will be 2 times 8.9 plus 7.5 plus 6.9 plus 6.4 plus 5.6. And I got 70.6.
Okay.
So the smallest, so it all depends, as I said, if the function is increasing or decreasing. That's all it means.
I have a question.
Yes, I'm ready.
Okay. This is from 5.5, and it was evaluate the indefinite integral of x cubed root x squared plus 33 dx.
The square root?
Yes, of x squared plus 33 dx.
Okay. I remember doing this last time. I'm checking. Maybe not. Here it is. The only difference is that there is a 41 and you have a 33.
Oh, okay.
We can do it again. I don't mind.
Yeah, could we do it again, please?
Yep. So we have let u be x squared plus 33. So du equals 2x dx. So we needed 2, obviously. And please understand that if you have in the same integral x and y or u, whatever else you use, whatever variable you use, you cannot get credit for it. Please understand that, please. Okay, so the 2 and 1x with dx will be the du. This is the u to 1/2, but we also have a remainder of x squared in here, which will be u minus 33. Then we distribute. u to 1 plus 1/2 3/2 minus 33 u to 1/2 du. And then we have 1/2 u to 3/2 plus 1, which is 5/2 over 5/2 minus 33 u to 3/2 over 3/2 plus a constant c. So when I flip, I get 1/5. U, now I have to go back to it, x squared plus 33 to 5/2. I flip, so I get the 1/2 in front, so minus 1/2. And this will be 33 times 2 over 3. And x squared plus 33 to 3/2 plus a constant c. So 1/5 x squared plus 33 to 5/2 minus 11 x squared plus 33 to 3/2 plus a constant c.